Let's get this lesson on trigonometry started with a great joke. What type of math do trees do? Of course, trigonometry. Let's have a look at the right angle triangle for a moment. Trigonometry only uses in grade 10 the right angle triangle, so note the 90-degree angle in the corner. Also note the label A in the bottom right-hand corner of the triangle. That's our reference angle. So a reference angle will always be one of the two acute corners, and it will be named a letter. It could be named a Greek letter, or it could be a number, for example, 32 degrees. From our reference angle, we have to label the sides. So the easiest one to do is, of course, the hypotenuse. The hypotenuse is the longest side of any triangle, and it's opposite from the 90-degree angle. The opposite, now imagine standing at the reference angle and throwing a ball straight across. That would be where you would be throwing it to the opposite. And of course, another word for adjacent is beside. So the side that is beside the angle will go right here. Now, let's have a look at a second triangle. Notice that we've moved the reference angle from the bottom right to the top left corner, and I've called this reference angle B. Now, what happens when we label the sides from a reference point? Remember, hypotenuse is always the longest side. If you're standing at B and you throw a ball, where does the ball go? Well, it goes straight across to the opposite. And which side is beside the angle side? The adjacent. So notice that when you are labeling it from a different reference point, you have the adjacent and the opposite switching. The hypotenuse never changes. It's always across from the 90-degree angle, and it's always along the side of the triangle. Let's have a look at one of the trig ratios. The first one is sine, S-I-N-E. So what we're going to look at is four triangles, and we're going to look at the way they've been labeled. So let's have a look at these triangles. So for example, if we start at this reference point and we go across, we find that this is the opposite and this is the hypotenuse. So from that ratio, we have those two sides marked. Okay, let's have a look at the next one. From this reference point, if we have these two sides selected, from here on this side, this is the opposite, this is the hypotenuse. All right, let's carry on. If we have these two sides selected, from the reference angle, look straight across. This is your opposite, this is your hypotenuse. And let's look at the last one. So from this reference angle, if these two sides are selected, again, we have an opposite and we have a hypotenuse. So let's have a look and summarize what we know about sine. So now we can make some assumptions. The sine ratio only uses the two sides, the opposite and the hypotenuse. So the sine, which is the trig ratio, of some angle. Now the angle might be written as a number, 32 degrees, might be written as a Greek letter, maybe called theta, maybe as a variable like x, is equal to opposite over hypotenuse. The opposite and the hypotenuse refer to the lengths of the sides of the triangle with those two variables. All right, let's look at our second ratio, cosine. Again, if you have a look at the screen, we have some triangles, and I figured out how to put red dots for reference angles, so here we go. So from the reference angles, you can see that from this reference angle on the first one, this one here, we have nothing on the opposite. So this time we have the hypotenuse worked out and the adjacent. So what we have is the adjacent and the hypotenuse. All right, let's go to the one on the right. Again, from the reference angle, you can see that we have a hypotenuse and an adjacent. So here's my hypotenuse, and here's the adjacent. All right, from the next reference angle, you can see again, nothing on the opposite. So this is the hypotenuse, and this is the adjacent. And our last one, again, nothing on the opposite. So this is our adjacent, and this is our hypotenuse. So you can make some assumptions now that the ratio for cosine has only to do with two sides, A and H. And if we use the same pattern as before, we'll find out what the cosine ratio is. All right, let's have a look at the cosine ratio. So the trig ratio first, so cosine, again, this time I've used theta for the angle, but we could use a capital letter. We could use 22 degrees. And the ratio is the length of the adjacent over the length of the hypotenuse. So that's your cosine ratio. All right, here's our third ratio, the tangent ratio. Have a quick look at all the triangles and see what side hasn't been ticked. You got it right if you said the hypotenuse. So in this case, you can see that from our reference angle, we have an opposite and an adjacent. We have an opposite, adjacent, opposite, adjacent, and opposite and adjacent. So the two sides that have anything to do with trig ratios are O and A. All right, let's have a look at the tangent ratio. So the tangent ratio, the tangent of theta, again, could be a letter, could be a number, 25 degrees, is equal to opposite over adjacent. All right, let's quickly talk about sohcahtoa. You may have heard some of your older brothers or sisters talking about sohcahtoa. So sohcahtoa is a mnemonic device that helps us remember the ratio and the connected sides. So SO stands for the sine ratio, and the two sides opposite over hypotenuse. CAH stands for the cosine of the ratio is adjacent over hypotenuse, and the T stands for tangent, stands for opposite over adjacent. So before you go any further, please make sure you've memorized all the ratios. You can identify all the sides, and we need to know that before we go any further. Let's just have a look at the structure of a trig ratio. So now that we know the three ratios, you're always going to start with either one of sine, cos, or tan. The next piece of the puzzle beside that goes the angle. Now, the angle might be a number, let's say 76 degrees. It might be a letter, capital A. It might be a Greek letter, theta. You always have the equal sign. It's equal to the ratio. Now the ratio might be a fraction, for example, 4 over 5, or a decimal. The decimal might be 0.345. So we're going to talk about in a minute the values that these decimals can take on, but this is what every question should have. A ratio, an angle, an equal signs, and a ratio in the form of a fraction or a decimal. In trigonometry, we definitely need our calculators or we need trig tables, which we'll talk about later. But for now, this is going to be a big moment for you. You can finally use the buttons right here, sine, cos, and tangent. You'll also need to know your second function key or shift key on your calculator. Please make sure that your calculator is in degree mode. So if you can find your mode button, make sure somewhere on your screen, although I can't see it on mine, it says D, DRG, or DEG. All right, let's actually get to work trying to find some ratios. So I've given you a triangle, right angle triangle with a reference angle called A, and I've given you side lengths 1, 1, root 2. When we're finding side lengths of right angle triangles, we always use Pythagoras to find the missing side, so that's why everything is still in its square root, and I would prefer it to be in that form. So let's go ahead and start with our basics. What do we do first thing when we find a triangle is we label the sides. Well, we're standing at A and we throw a ball. This becomes our opposite. The longest side is always the hypotenuse, and the side beside the angle that we're talking about is the adjacent. Now we can see that A has a length of 1, opposite has a length of 1 unit, and hypotenuse has a length of root 2 units. So we can remember our mnemonic, sohcahtoa. I prefer it written in this form rather than a horizontal form so that we can see the structure of the trig identities. And here we go. Sine A is equal to opposite over hypotenuse, which is 1 over root 2. Cosine is equal to 1 over root 2, adjacent over hypotenuse. And A is opposite over adjacent, which is 1 over 1, or just 1. Let's take that same triangle and just add a bit of information. This is a special triangle. It's an isosceles triangle, and the corners are 45 degrees in each corner and 90 in the right angle, of course. So now what I'd like you to do is I'd like you on your calculators to find out what is the sine of 45 degrees. I'll wait while you do that. All right, this is what you should have on your calculator. You should have the sine of 45 equals, and if you notice I have degrees here, 0.707106781. So that's the ratio of the sine of 45. So let's check that against the answer that we got in the previous slide, which is the sine of some known angle, sine of 45 degrees, equals 1 over root 2. So go ahead and put 1 over root 2 into your calculator. Well, what have we just discovered? That 1 over root 2 is actually 0.707, etc. So we've now found out that our calculator has a way of finding out the ratio for every known angle. And I'm going to tell you how it does it.